Okay, so hopefully this is working. I have a daft little concept that I wanted to go through for ground control points. So when you're doing a survey and you've got a whole bunch of your ground control points, people often ask me how far apart should these ground control points be? Now, for a start, you need to work out how many ground control points you should have. So imagine that you have a point in space and you want to confirm exactly where that point in space is. How many ground control points would you need to confirm the location of a point? I'm not being facetious, but hopefully it'll be obvious to you that the answer is one. You need a ground control point for a point. If we had a line and you were looking to stabilize a plane so that it was fixed in space, hopefully you can realize that you need not just one ground control point, but you also need another ground control point in order for everything in between to be stabilized to a line. Then we start to get more complex about our thinking. What if you have a plane? Hopefully, you'll realize that you can't just put two ground control points on this because obviously this whole thing here could then rotate. So what you need to stabilize a plane is at least three ground control points. Now, that would cause everything to be fixed in space, and you can understand that. Now, you might think then that the answer is, oh, we only need three ground control points for any of our surveys. However, we don't live in a world of flat Earth. Well, hopefully we don't live in a world of flat Earth. What we actually do is we live on the Earth. Now, if we look at this in two dimensions and you want to get a circle to fit and be controlled, you can't just put in two ground control points because there are an infinite number of circles that could fit that. Hopefully you can see that you can have an awful lot of circles that would fit a plane. Actually, if you want to stabilize a circle, you need three ground control points. Again, this is a simplification. What we actually deal with is we live on a sphere or a spheroid. So I'm going to kind of draw it, but it's a difficult thing to draw. So we've got a circle and it's got an axis kind of like that. If we put in enough control to stabilize our model to a spheroid, we actually don't need just two or three ground control points because with a sphere, three ground control points again could be an infinite number of sphere spaces. We could actually have an infinite number. So what we need for a spheroid is a minimum of four ground control points to correct to a sphere. So then people say, oh, so we only need four ground control points. Well, yeah, except one of these things might not work. One of these things might have a bad measurement be taken. And at this stage, of course, we've got enough to control our model, but we don't have enough to check our model. So in an ideal world, you'd also have some redundant control in and amongst all of this to actually verify the accuracy of your model. So this is the philosophy of ground control points. We live in a sphere, so you need a minimum of four to correct to a sphere, but we also need some additional survey control to check and have some redundancy. Right, hopefully that worked.